Hi students, welcome to physics classes. Now we are discussing 10th class physics model paper 3. Now we will discuss today model paper 3. Now the first question is 1 mark questions. We will get total 8 questions. 5 physics, 3 chemistry. 5 physics, 3 chemistry. Now the first question is convert 25 degrees Celsius into Kelvin scale. Students, remember one thing. Now whatever we are discussing, these numbers will change in the exam. Here I am saying about 25 degrees Celsius. In exam they can ask you 20, 30, 40, whatever it is they can ask. If you understand the procedure, you can do whatever the number they given. Now whenever they given Celsius scale and asking to convert Kelvin scale, we should add 273. We should add 273. Kelvin equal to centigrade plus 273. C plus 273 we should add. Now C 25 they given plus 273, total 298 kelvins. If they given Celsius asking you to convert kelvins, we should add 273. Suppose kelvins given asking to convert degree Celsius. Now we should do minus 273. So C equal to this plus 273 coming this side minus K minus 273 we should do. Understand the procedure and apply to any type of question. Next, why do stars appear twinkling? Why do stars appear twinkling? Stars are actually they are not twinkling. Actually they are not twinkling. It appears they are twinkling. It appears they are twinkling. That's why do stars appear twinkling? Now stars appear twinkling, that is because of atmospheric refraction. Because of atmospheric refraction, stars appears twinkling. Now if this question is asked for 1 marks, if you write because of atmospheric refraction is enough. Sometimes if this question they are asking 2 marks, so we should learn still more. Now the star light reaches the surface of earth after traveling through many layers of atmosphere. The light from the stars reaches the surface of earth after traveling through many layers of atmosphere. After traveling through many layers, light reaches to the surface of earth. These all layers are having different densities. These all layers are having different densities that causes different refractive index. Different refractive indexes. So number of times light ray suffers deviation. Number of times light ray suffers deviation. So we are able to see the apparent position of the star that appears as twinkling. That appears as twinkling. When light ray coming like this, we can see star like this. If it is bending, we can see star here. When light ray coming like this, for example, we can see the star here. If it is bending like this, we can see the star here. So like this, number of times light ray changes its path, bending, number of times it is bending because of different layers, different densities, different refractive indexes. So we are seeing the apparent position of the star. Apparent position of the star which we see as twinkling. Okay. If they ask for 1 marks because of atmospheric refraction, more 2 marks or like that if they ask, we should write these points also. Okay. Next question, assertion and reason. For 1 marks, next question, assertion and reason. These type of questions, compulsory one question they are asking, like assertion, reason. Now the first, this one is, assertion is for total internal reflection. For total internal reflection, light must travel from denser to rarer medium. To form total internal reflection, light rays should travel from denser medium to rarer medium. Yes, assertion is true. Next, reason. In such situations, rays bends towards normal. When light ray traveling from denser medium to rarer medium or during total internal reflection, light ray bends away from the normal. Light ray bends away from the normal. But what they given? Towards. It is wrong. Assertion is true. Reason false. Wrong. Okay. What is the correct answer? Bends away from the normal. Okay. Next, draw neat diagram of lens. Generally for 1 marks, they will ask draw a neat diagram of biconvex lens, biconcave lens, plano-convex, plano-concave, concavo-convex. Whatever the lenses we are having, that all, any one they will ask in the exam for 1 marks. So instead of 1, 1, 1, 1, 1, I will tell you all diagrams at a time. Then one time learning, you can write any type of question. Draw a neat diagram of a biconvex lens, biconcave lens, plano-convex, plano-concave, concavo-convex. Now, first one is biconvex. Bi means two surfaces. Two surfaces are convex. It will be like this, convex. Biconvex lens. Next, biconcave. Biconcave. Two surfaces, concave. Concave, bends inside. This is biconcave lens. Next, plano-convex. Plano-convex means one side plane surface, second side convex surface. Plano-convex. We should draw like this also. One side plane, other side convex. There is no restriction. First side convex, first side plane, like any like it will be. Next, plano-concave. Plano-concave. Plane concave. I already told you, no restriction. Which side plane, which side concave. Like that we can. One side should be plane, one side concave. Next, concavo convex. One side concave, another side convex. Convex, concave. Like this we can draw. Or convex, concave. What is the difference here? Sharp edges, here blunt edge. Thickness is more here. These are the different types of lens. Next, what are the minimum and maximum focal length of eye lens? Eye lens. Minimum focal length, maximum focal length. F minimum, F maximum. F minimum is 2.27 centimeters. Minimum focal length of eye lens is 2.27 centimeters. Maximum focal length of eye lens is 2.5 centimeters. 2.5 centimeters. 2.27 centimeters. 2 point. Remember this. In this lesson, human eye, we are learning least distance of distinct vision 25 centimeters, and after that we are learning maximum focal length of eye lens is 2.5 centimeters. Students are getting confusion. They are writing differently. For the least distance of distinct vision, they are writing 2.5. For maximum focal length, they are writing 25. Okay. Think before writing. Think before writing. Least distance of distinct vision. What is the minimum distance, least distance that we are able to see? 2.5 centimeters. If you keep an object, can you see? No. 25 centimeters. If you keep an object, you can see. Teachers are saying, elders are saying, our parents are saying, we should not keep our book very close to the eyes while writing or reading. It should be some far. So more distance, 25 centimeters. Least distance of distinct vision. Maximum focal length of eye lens. Before writing this answer, if you get any doubt, once you check the thickness of your head, it is not even 20 centimeters. Your head size is not even 20 centimeters thickness of head. How eye lens will be eye size will be 25 centimeters? Not possible. Your eye size is very small. So a maximum focal length is 2.5 centimeters. Very important question. Next, the focal length of converging lens. Converging lens means convex, biconvex lens. Diverging lens means biconcave lens. The focal length of converging lens is 20 centimeters. 20 centimeters. So f equal to 20 centimeters. An object is 60 centimeters from the lens. So object distance is 60 centimeters from the lens. Where will be the image be formed? Where will be image formed? So we should find. And what is the kind of image is it? What kind of image is it? So we should write the nature. First we will discuss V. We have to find image distance. We have lens formula 1 by f equal to 1 by v minus 1 by u. So 1 by v we should find, 1 by u will take to that side. So we will write 1 by v equal to 1 by f, that is coming this side, becomes plus 1 by u. So I substitute here 1 by f, focal length of the converging lens, convex lens, biconvex lens, positive 20 centimeters. Object distance, sign convention, negative minus 60. So 1 by 20 plus 1 by minus 60. Minus into plus minus. Directly I am writing LCM 60. Here 23 times minus 1 time. So 1 by V equal to 3 minus 1, 2 by 60. That becomes 1 by 30. So image formed is at 30 centimeters. Image distance is 30 centimeters. Now what is the nature of image? Nature of image. Now convex lens, we know the ray diagrams. Focal length is 20 centimeters. So radius of curvature or center of curvature 2f is 40. So object is placed at 60 centimeters. Object is placed at 60 centimeters. So beyond center of curvature. Object is placed beyond center of curvature. Now what is the nature? Already we found image distance between focus and center of curvature. Image formed between focus and center of curvature. So size will be diminished. And nature real and inverted. Directly we can write if you remember the ray diagrams. Ray diagrams I already explained. It is there in our channel once you go through it. Next question. Plus 50 centimeter focal length. Focal length is 50 centimeters. Biconvex lens. Remember, whenever they given plus 50 centimeters, we can understand that is biconvex lens. No doubt about it. Positive focal length, biconvex lens. Negative focal length, biconcave lens. Recommended to correct the defect of vision of a man, find the power. We have formula for power equal to 1 by f in meters. If focal length is given in meters, we should use power equal to 1 by f. If they given in centimeters, power equal to 100 by f in centimeters. Now they given 50 centimeters, no? So power equal to 100 by 50, that equal to 2. 2 times cancel. What is the unit of power? Diopter, D. 2D lens. 2D is the power of lens. Next question, 4 more questions. In 4 more questions, first question is having internal choice. One is physics, next one is chemistry. 13th question is physics, 14th question is chemistry. So any 3 you should write. Now find the refractive index of the glass which is a symmetrical convergent. I told you convergent lens. Convergent lens means convex lens. Its focal length is equal to radius of curvature. Focal length is equal to radius of curvature. Symmetrical they given. So R1 is equal to R2 equal to R we can take. R1 equal to R2 equal to R we can take. Now to find the refractive index and for they given focal length radius of curvature relations, we should take lens maker formula. 1 by f equal to n minus 1 into 1 by R1 minus 1 by R2 is the formula. So 1 by f, 1 by R equal to n minus 1 into 1 by R1. R1 is a R minus 1 by R2. R2 sign convention we should take. This is negative. So minus into minus becomes plus 1 by R. We will have two surfaces. We have two surfaces. This surface R1 this side. This surface R2 this side. So opposite to the direction of incident ray, sign convention minus. So we will write 1 by R equal to n minus 1 into 1 by R plus 1 by R. R is LCM, 1 plus 1, 2. 2 by R. R gets cancel. 2 coming this side, 1 by 2. So 1 by 2 equal to n minus 1. Minus 1 also coming this side, plus 1. 1 by 2 plus 1. I'll write here n equal to 1 by 2 plus 1 is 3 by 2. 1 by 2 plus 1 is 3 by 2. Now 3 by 2 we can write that is 1.5. So what is n value? 1.5. N equal to 1.5. That is the refractive index of glass. That is the refractive index of glass. Next question is, what do you mean by electric shock? Explain how it takes place. What do you mean by electric shock and explain how it takes place? Electric shock. It is from the lesson electric current. From the lesson electric current. I explained this in a video. It is available in our channel. Please go through it. Electric shock. Total chapter I did. Electric current total chapter I did. In that one of the topic is electric shock. You can go through it. That link I will provide you in the description. Next question. Explain the procedure of finding specific heat of solids experimentally. This is the lab activity from chapter heat. Finding the specific heat of the given solid materials or determination of specific heat of given solid materials experimentally. That I explained in the chapter heat. It is available in our channel. Please go through it. Finding the specific heat of solids. Finding the specific heat of solids. That link I will provide you in the description. Now next question. Choice for previous question is, explain Faraday's law of induction with the help of an activity. Explain Faraday's law of induction with the help of an activity. Now to do this experiment, we require galvanometer and a coil, bar magnet. Galvanometer, coil, bar magnet are required. Now the procedure, first we should take the coil. This is coil, means a wire. Ends of the coil connected to the galvanometer. Ends of the coil connected to the galvanometer. Nothing is there, no source, battery, like that. Anything is not connected. Only coil we have taken, that is connected to the battery. Connect the terminals of the coil to the galvanometer. Now here we won't expect any deflection in the needle of the galvanometer. because there is no EMF in the circuit. Because there is no EMF in the circuit. Galvanometer not deflects. Now we'll take a bar magnet and push this bar magnet towards the coil by north pole facing towards the coil. North pole facing towards the coil. Then we can find deflection in the galvanometer. We can find deflection in the galvanometer. Now what we did here, we have taken bar magnet. We pushed this bar magnet towards the coil by facing north pole towards the coil. When it is moving towards the coil, we found deflection in the galvanometer. Generally, galvanometer does not deflect if there is no current, no EMF in the circuit. When we are pushing it towards the coil, when we are pushing the magnet towards the coil, galvanometer is deflecting. Galvanometer is deflecting. When the magnet is at rest, galvanometer is not deflecting. When it is moving, bar magnet is moving towards the coil, galvanometer is deflecting. If it is not moving, galvanometer is not deflecting. That means we can identify there, when it is moving, current is generating, galvanometer is deflecting. When it is not moving, when it is kept at rest, galvanometer not deflecting, no current is generated. Next, when the magnet is moved away from the coil, initially we move towards, next we will move away from the coil. When the magnet is moved away from the coil, again galvanometer is deflecting, but in the direction opposite to the previous. When moving towards, it is deflecting in one direction. When moving away, it is deflecting in other direction, opposite direction. That indicates current generated in the coil is opposite to the previous direction. Current generated in the coil is opposite to the previous direction. Okay, now we see north pole facing towards the coil and moving towards the coil and away from the coil. Next, reverse it. Now if we push the south pole of the magnet instead of north pole. Initially we kept north pole towards the coil, moved towards and away. Now reverse it. South pole facing towards the coil and moving towards the coil. Current will be generated. But opposite to the previous case. That means when north pole facing towards the coil, moving inside, and south pole facing towards the coil, moving inside, both times current generated is opposite. So what happened here? Magnetic flux linked to the coil. Magnet produces magnetic flux. That magnetic flux linked to the coil changes. Then current will be generated. That's why when it is moving, current is generated, either moving towards or moving away. Relative motion between coil and magnet. No matter here coil is moving or magnet is moving, one should be moved. That's all. So whenever it is moving, either coil is moving or magnet is moving, magnetic flux linked to the coil changes, then current will be generated. That is the conclusion. What is conclusion? Whenever there is continuous change in magnetic flux linked to the closed coil, current is generated in the coil. Very, 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 very important question. Next question. How do you verify experimentally angle of refraction is more than angle of incidence? Angle of refraction is more than angle of incidence. When light ray travel from denser medium to rarer medium, rarer medium. This is activity. When light ray traveling from denser medium to rarer medium, angle of refraction is more than angle of incidence. From lesson, refraction of light at plane surfaces. From plane surfaces, very important activity I explained in a video. It is available in our channel. You can go through it. That link I will provide you in the description. Okay, this is model paper 3. Thank you for watching. Please subscribe for more updates.